This is a key to radicals worksheet number 1, and the directions state simplify each radical and then assume that all variables represent positive numbers. So in that case, since the variables represent positive numbers, we don't have to worry about when we take the square root of a variable raised to a power, whether it's even or odd, we don't have to worry about any absolute values. Okay, so number 1, we want to simplify the square root of 112. All right, so I'm going to go ahead and do the work on a separate sheet of paper. All right, so number 1, the square root of 112. Now remember, there are no variables in this one, so basically you just want to ask yourself, what's the largest perfect square that goes into 112? And so the largest would be 16. And so we get the square root of 16 times 7. So if you need to use your calculator, use your calculator. And then using the product rule, we can write this as the square root of 16 times the square root of 7. And remember, the whole purpose of using a perfect square was that when you take the square root of 16, you just get 4. And so the answer here would be 4 square root of 7. And remember, I cannot simplify the square root of 7 because the only perfect square that goes into 7 is 1. All right, so that's the answer to number 1. All right, so the square root of 12 would be 4 times the square root of 7. Now, let me just say this. There are some of you that are going to say this, so I'm just going to go ahead and say it. So you're going to say a perfect square that goes into 112 is 4. The problem is that 4 is not the largest. So here's what you're going to have to deal with in that case. So 112 divided by 4, you're going to get 28. And then from here, you can recognize there's still a perfect square that goes into 12 besides 1, and that's 4. So you're going to say 4 times 28, and then what you have to do is you're going to have to say, well, that by the product rule, that's going to be the square root of 4 times the square root of 28, and then the square root of 4 is 2. But I can still simplify the square root of 28, so you got to go further. And so the perfect square that goes into 28 is 4, so I can rewrite the square root of 28 as the square root of 4 times the square root of 7 using the product rule. And so the square root of 4 is 2, so you get 2 times the square root of 7, and so that's 4 square root of 7. So you see you get the same thing, but it's so much easier to use the largest perfect square rather than any perfect square that divides into the radicand. All right, so that was number 1. Number 2, we have the square root of 150. So the same idea, so we're going to pick the largest perfect square that goes to 150. And so in number 2, the largest perfect square that goes to 150 is 25. So I'm going to write this as the square root of 25 times 6. And so remember, using a product rule, I can rewrite this as the square root of 25 times the square root of 6. And the square root of 25 is a perfect square, so the square root of 25 is 5. So you get 5 square root of 6. And I cannot simplify the square root of 6 because the only perfect square that goes into 6 is 1. So that's answer number 2. So number 2, we get 5 square root of 6. All right, number 3, we have the square root of x to the 22nd power. All right, so when the index is 1, so the thing is this. So you can simplify a variable raised to a power if that exponent is greater than or equal to the index, and it is. All right, now the good thing about this one is that the exponent is even and my index is even. So all you got to do to figure out, and remember, you're just figuring out, well, what times itself twice is x to the 22nd. All right, well, you know it's going to be x to the 11th because x to the 11th times x to the 11th is x to the 22nd. Remember, when you multiply like bases, you add exponents. But basically, all you need to do is just ask yourself, 22 divided by 2 is 11. So that becomes x to the 11th. So when the exponent is even, you're dealing with square root, that's an easy kind. And again, I don't have to worry about absolute value here. So whenever you're taking the square root of a power raised to a variable raised to an even power, you may at times have to deal with absolute values. But the fact is that all variables represent positive numbers, so we don't have to do that. All All right, so the answer number 3 is x to the 11th. All right, so x to the 11th. All right, now number 4. So number 4, we have, I'm going to go ahead and put number 4 here. So number 4, we have the square root of x to the 13th. Now the problem with that one is that 13 is odd. So you, and I can simplify this because 13 is greater than or equal to 2. And so I'm going to have to rewrite this so that way I'm going to use the product rule. I'm sorry. When you multiply bases, you add exponents. So I'm going to use that rule here for exponents. And so basically you're asking yourself, x to what even power times x to what odd power equals x to the 13th. Now remember that part you put here, that even power you put here, you want to use the largest possible. So what's the largest number, largest even number that's less than 13 that 2 divides into? Will be x to the 12th. And so x to the 12th times x, because remember that's understood to be x to the first, is x to the 13th. Now using the product rule, we get x to the 12th times the square root of x. And so the square root of x to the 12, just like we did here, 2 into 12 is 6. I get x to the 6. And it makes sense because x to the 6 times itself is x to the 12th. And then times the square root of x. Now remember, this cannot be simplified because the exponent, which is 1, is less than the index. So that's the answer to number 4. So we get x to the 6 times the square root of x. So x to the 6 times the square root of x. All right, number 5, we have, I'm going to do number 5 here. Number 5, we have the square root of 27, a to the 3rd. All right, so let's go ahead and use a product rule here first. So that's going to be the square root of 27 times the square root of a to the 3rd. All right, so let's talk about the square root of 27. Let's deal with that. So the square root of 27, I can simplify because the largest perfect square that goes into 27 is 9. So I can write this as square root of 9 times the square root of 3. Now, here I'm dealing with the square root of a variable raised to a power. So that's this idea here, and that power is odd. So you want to use the largest, so you want to rewrite it to where, as a product, to where the largest exponent of one of them is even, and it's less than that power. So here, that's going to be x squared, a squared, to the square root of a squared times the square root of a. It makes sense because a squared times a is a cubed. All right, now let's simplify what we can. I can simplify this one, and I can simplify this one. So the square root of 9 is 3 times the square root of 3. The square root of a squared is just a, because a times a is a squared. And I cannot simplify the square root of a because the exponent of a, which is 1, is less than 2. Oops. All right, now you got to rewrite this. You can't leave your answer like this because you know that when you're dealing with square roots, that you can multiply the radicands. You can write this as 1 radical. And always put the radical at the end. So we get 3 times a. Remember, all this is products. You're multiplying. So 3a times the square root of 3 times a is 3a. All right, so that's the answer to number 5. All right, so 3a times the square root of 3a. All right, number 6, we have the square root of 50, a to the 8th power, b to the 5th. All right, so again, do this idea here. So that's going to be the square root of 50 times the square root of a to the 8th times the square root of b to the 5th. All right, and then let's deal with the square root of 50 first. So the largest perfect square that goes into 50 is 25. So I can write this as square root of 25 times the square root of 2 using a product rule. Makes sense because 25 times 2 is 50. And 25 is a perfect square. Now here, the exponent is even, and so that's going to be the easy kind. So what times itself twice is a to the 8th? Well, a divided by 2 is 4, so it would be a to the 4th. Now this is odd, so I have to rewrite it. So I'm going to rewrite this as the square root of b squared times the square root of b. All right, so I can simplify this and this in terms of square roots. So the square root of 25 is 5, so you get 5 square root of 2 times a to the 4th. I can simplify this. The square root of b squared is b times the square root of b. Now remember, you got to rewrite this, the product of those square roots as 1. All right, so let's put everything else first. I get 5 times a to the 4th times b. So 5 times a to the 4th times b times the square root of 2 times the square root of b is the square root of 2b. Now make sure as you write this that it does look like b is under the radical. Make sure it looks like a is under the radical, so you need to extend it if you have to, so there's no ambiguity. All right, so that's the answer to number 6. Number 6, you have 5a to the 4th. Sorry. So that was, let's go back over here. That's a 5. I thought that was a 3. So that's a 5. So this is a 4, right? So that's going to be b squared. Okay, the square root of b to the 4th is b squared. So that's a 5 right here. All right, that's a 5. I thought it was a 3. So that's b to the 4th, so that's b squared, correct? Because b squared times b squared is b to the 4th. All right, so the answer number 6 is 5a to the 4th, b squared, times the square root of, what's that, 2b? Okay. All right, number 7. Number 7, we have negative 4 times the square root of 45. All right, so there are no variables here, so that should be the easy kind. So I get negative 4. Now, we got to simplify the square root of 45. So the largest perfect square that goes into 45 is 9. So I can write this as square root of 9 times the square root of 5. 9 times 5 is 45. And I can simplify this. Square root of 9 is 3. So I get negative 4 times 3 times the square root of 5. And so negative 4 times 3 is negative 12. So you get negative 12 square root of 5. So that's answer number 7, negative 12 square root of 5. All right, number 8, we have this. We have 3 times the square root of 20, a squared b. All right, so let's go ahead and use the product rule and rewrite this. So I'm going to rewrite this as 3 times the square root of 20 times the square root of a squared times the square root of b. All right, now what perfect square goes into 20? I can simplify that because 4 will go into 20 evenly. And so I get 3 times the square root of 4 times the square root of 5. I can automatically simplify this right now because the exponent's even. 2 divided by 2 is 1, so a times a is a squared. I cannot simplify this because the exponent is 1 and 1 is less than 2, the index. So that's square root of 2. Okay, now let's go ahead and simplify what I can. So I know I can simplify the square root of 4, so that's 2. So you get 3 times 2 times square root of 5 times a times square root of b. And so 3 times 2 times a is 6a. And then I'm going to rewrite the two products here, those two square roots, as 1. So it'll be the square root of 5b. That's a 5 right here, 5b. All right, so that's the answer to number 8. So number 8, we get 6a times the square root of 5b. All right, number 9, we have this. For number 9, we have 2x times the square root of 675 x to the 4th. All right, now 675 is a large number, right? So what I would probably do first is let's see if 675 is already a perfect square. All right, so let's just check that. So we're going to do square root 675, and it is not a perfect square. All right, so then we need to kind of go through the process then and see what's the largest perfect square that goes into 675. Now we know that 25 does, so let's do this. 675 divided by 25. Now notice that we have 27, so 25 times 27 is 675. But here's the issue, 25 is not the largest. So if you wrote it as 25 times 27, at some point you're going to have to simplify the square root of 27. So let's just deal with the largest factor now. So notice what perfect square goes into 27? Well, 9. So I now know the largest perfect square. It'll be 25 times 9. So 25 times 9 is 225. All right. So I'm going to rewrite this. I'm going to rewrite this as 2x times the square root of 225. All right, so 675 divided by 225 gives me 3. So times the square root of 3 times the square root of x to the 4th. Okay? All right, so let's simplify what we can. I can simplify this. I cannot simplify this, but I can simplify this. So I get 2x, the square root of 225. If you have to use your calculator, you use your calculator. So the square root of 225, let's see, square root of 225. Make sure you know how to use your calculator. So remember, give a second square root and then 225, and you should get 15. So we get times 15 times the square root of 3, and then since this exponent's even, that's the easy kind. The square root of x to the 4th is just x squared, because x squared times x squared is x to the 4th. And so now 2 times 15 is 30. Okay. Now look at this. You have x times x squared. So when you multiply like bases, you add exponents. So x times x squared is x cubed. So I get 30 x cubed, and then what? Square root of 3. Okay, so 30 x cubed times the square root of 3. All right, so that's the answer to number 9. So 30 x cubed square root of 3. All right, and then final number 10. Let me go ahead and put number 10 right here. So let's be number 10. So number 10, we have the square root of x to the 9th, y to the 10th. So the purpose here is just to remind you how to deal with when we're taking square roots and the one exponent is odd and the other one's even. So if it's even, that's the easy kind. But let's go and use the product rule. So it'll be the square root of x to the 9th, square root of x to the 10th. And so remember, when the power is odd, when the exponent is odd, you want to rewrite this as the product of two factors of x. So we get the square root of x to the, and then remember, you want one of the exponents to be an even number, and you want it to be the largest even number possible that's less than 9. So that's going to be 8. So the square root of x to the 8th times the square root of x, square root of x to the 9th, and then since this is even, we're just going to rewrite this as square root of x to the 10th. Now, I can simplify these two because those exponents are even. So the square root of x to the 8th is x to the 4th. Oh, that's supposed to be y, right? I'm sorry. That's supposed to be y right here. And this square root of x, and then this right here, the square root of y to the 10th is y to the 5th. And so therefore the answer, always put the square root at the end so you don't mess up. Because if you put it if you put something else behind it, it may look like it's under the square root and you may lose some points. So it'll be x to the 4th, y to the 5th, square root of x. All right, so that should be the answer to number 10. So number 10, we have x to the 4th, y to the 5th, square root of x. All right, so that is the key to worksheet number 1. All right.